Let's look at question 1 to 10 of the 2020 JAMB Chemistry examination questions. Question 1 says, an electron can be added to a halogen atom to form a halide ion with A. 2 valence electrons, B. 3 valence electrons, C. 7 valence electrons, D. 8 valence electrons. So what is the answer to this question? First things first, they said an electron can be added to a halogen atom. First things first, what's a halogen atom? For a halogen atom, don't forget that when it comes to the halogens, now recall that for the halogens, when we talk about halogens, we're talking about those elements in group 7. So halogens are group 7 elements. So group 7 elements. Examples include bromine, Br, fluorine, F, chlorine, Cl, iodine, and etc. So what you have here are some of the basic and most popular halogens. One thing that characterizes these halogens is that they are group 7 elements, which means that they have 7 valence electrons. That means for a halogen, the number of electrons on the outer shell is 7. So you have something like 1, 2, that's 2 electrons, 3, 4, 4 electrons, 5, 6, 6 electrons, then 1, that's 7. So for a halogen, you have 7 electrons on the outermost shell. Now, if they say that an electron can be added to a halogen, if I add an extra electron, let's use X now. If I add an extra electron, X here, in total, how many valence electrons do you have? You have 1, 2, 3, 4, 5, 6, 7, 8. So if I add an extra electron to the halogens, you have 8 valence electron. So the correct answer here is D, 8 valence electron. That's your answer. Question number 2. When steam is passed over red hot carbon, the substance produced are, so this should be substances, right? The substances produced are, let me correct this. The substances produced are A, hydrogen and thiazocarbonate 4 acid, B, hydrogen, oxygen and carbon 4 oxide, C, hydrogen and carbon 2 oxide, D, hydrogen and carbon 4 oxide. Now for question 2, you want to note that hydrogen and carbon 2 oxide or carbon monoxide will be formed when red steam is passed over red hot carbon. So the correct answer to this question is actually option C, hydrogen and carbon 2 oxide. So this will be the product when steam is passed over red hot carbon. Question number 3. 3 says there are basic particles from which matter could be made, except this should have been these are, right? Just a typo error. All right. 3 says these are basic particles from which matter can be made, except A, salt, B, atoms, C, ions, D, molecules. Now from this, we know that some of the building blocks or basic particles of matter includes molecules, atoms, and ions. Salt is not a basic particle from which matter can be made. All right. So the correct answer here will be A, that's salt. All right. Salt is not one of the basic particles. All right. The basic particles include atoms, ions, and molecules. Number 4, which of the activities is commonly used as a nuclear fuel? All right. So you have these elements here. These are actually elements. So which of these is commonly used as a nuclear fuel? A, uranium, B, palladium, C, actinium, D, thorium. Now for question 4, the correct answer is A, uranium, right? So uranium is a common nuclear fuel because it is less stable, all right? It has less stability, and as a result, it has a great tendency to increase energy. So the correct option here is A, uranium. Number 5, tartaric acid is used industrially to A, make baking powder, B, make fruit juice, C. Remove rust. D. Dry substance. What is the correct answer to this question? Now, for this question here, the correct answer there is B. Tartaric acid is used to make fruit juice. Now, you want to know that tartaric acid is the acid that is gotten from orange. All right. So, this tartaric acid is actually a type of acid that we get from orange, and it is used industrially to make fruit juice. That's orange juice. So, hence, the correct answer is B. All right. It is used to make fruit juice, and it is gotten from orange. Number 6. Diffusion is slowest in solid particles than in particles of liquid and gases because A. Solid particles have more kinetic energy than the particles of liquid and gases. B. Solid particles have less kinetic energy than the particles of liquid and gases. C. Solid particles have less restriction in their movement than liquid and gas particles. D. The particles in solid are far apart and the cohesive forces between them is or are negligible. Right? So for question 6, what is the correct answer? Now for question 6, the correct answer is B. All right. Solid particles have less kinetic energy than the particles of liquid and gases. Of course, we know that liquid and gases, we know that when it comes to the kinetic energy, gases have the most kinetic energy, followed by liquid and then solid. Okay. And also note that diffusion is the movement of molecules from region of higher molecules to region of lower molecules. As a result, solid particles have lesser kinetic energy than the particles of liquid and gases. So B becomes the correct option. Question number 7. Chlorine consists of two isotopes of mass number 35 and 37 in the ratio 3:1 and has an atomic mass of 35.5. Calculate the relative abundance of the isotope of mass number 37. All right. A 20, B 25, C 60, D 75. So how do we solve this question? Now, to solve this question, we are giving chlorine. So number 7, we're giving chlorine, right? And we're giving two isotopes of chlorine. The isotopes there are chlorine 35 and chlorine 37. So I'll come here and put chlorine, right? Atomic number 17. Then you have this as chlorine 35, and you have an isotope of chlorine, that's chlorine 17, chlorine 37. Let me just confirm that 35 and 37. All right. They said the two isotopes are in the ratio 3:1. All right, and they have an atomic mass of 35.5. Now we're asked to find the relative abundance of the isotopes. All right, we're asked to calculate the relative abundance of the isotope of mass number 37. How do we do that? Now we do not know the value of the relative abundance of chlorine 35, so we'd say let the relative abundance of chlorine 37, so you could also write it this way, right, of chlorine 37 bx. Now you want to take note that if I have the chlorine 35, let's start with chlorine 37. If I take the relative abundance of chlorine 37 as x, and I take for chlorine 35 as y, if you sum all the relative abundances, it should be equal to 100%. All right, and we know that 100% is equal to 100 all over 100, and that gives you 1. All right, so we're working with percentages, so that will be equal to, take this as 1. Let's express y in terms of x. If I have that y, x plus y is equal to 1, to get y, I'll move x over here. So y will be equal to what there? 1 minus x. We'll have this. So in essence, if the relative abundance of chlorine 37 is x, that of 35 becomes 1 minus x, which is y, as we just showed you here. All right. So what happens next is that the next thing you do is that you multiply the masses, right? That is the isotope. Multiply the isotope by its relative abundance. So 37 times X plus the next isotope is 35 multiplied by its relative abundance 1 minus X will be equal to the relative atomic mass of that particular element. So I'm having 37 times X, which becomes 37 times X plus the second one there, which is 35. That's the next isotope multiplied by its abundance we got as 1 minus X, of course expressed as a percentage, right? Then this is equal to the atomic mass of the element, which is 35.5. So this is equal to 35.5. We have this. Let's multiply through. This gives us 37 times X gives us 37X plus 35 times 1 gives us 35. 35 times minus X gives us minus 35. X is equal to 35.5. Next up, we have 7X, 37X. Next up, you have 37X minus 35X, and that gives you 2X. Then this one here plus 35, it's equal to 35.5. We have this. Next up, move this over here. We have that 2X, it's equal to 35.5. This moves over here, it becomes negative minus 35. Again, we have 2X is equal to 35.5 minus 35. That gives you 0.5. So this is 0.5. So 2X is equal to 0.5. Divide here by 2. Divide here by 2. This cancels this. So X is equal to 0.5 divided by 2. That gives you 0.25. Alright. So hence, the relative abundance of, recall that X represented the relative abundance of chlorine 37, which we've gotten here as 0.25. Your final task is to multiply this by 100%. Okay, remember that we converted this to 1. Initially, this one was actually 100%. We divided by 100. So at this point here, the final task here is to multiply this by 100. So this times 100, and that's equal to 25%. All right, so 0.25 in terms of percentage becomes 25%. So the correct answer there is 25. All right, so let's see which option that is. That is option B, 25. So that's your answer. All right, next up, question number 8. Question 8 says the principal constituent of natural gas is A, methane, B, ethane, C, propane, D, butane. So which of these is the correct answer? For this question there, the correct answer is A, methane. All right. So note that methane, this, of course, the formula there is CH4. Methane, CH4, is the principal and commercial constituent of natural gas. All right. So that's your correct answer. So your correct answer there is A, methane. Question 9. All these are electromagnetic waves except A, white light, B, photon, C, X-ray, D, infrared. What's your correct answer here? For this question here, the correct answer is B, photon, right? Photon is not part of the electromagnetic wave. Instead, it is a unit of energy that carries light and has zero mass. So photon is not part of the electromagnetic waves. Finally, question 10. Question 10, a change in temperature of a saturated solution disturbs the equation between the A, dissolved solute and the solvent, B, solvent and undissolved solute, C, dissolved solute and undissolved solute, D, dissolved solute and the solution. So what's the correct answer for this question? The correct answer for this question is C, dissolved solute and undissolved solute. You want to take note that temperature plays a vital role in equilibrium and the solubility of liquid. So therefore, a change in temperature of a saturated solution will alter the equilibrium between the dissolved and undissolved solutes. All right. So that's how we said dissolved solutes and undissolved solutes. So that's your correct answer. All right. So take note of this. Question 11 says, what is the volume of energy required to burn completely 45 cm cube of methane gas at STP, that's standard temperature and pressure? A, 135.0 cm cube, B, 150.0 cm cube, C, 45.0 cm cube, D, 90.0 cm cube. So how do we solve this question for number 11? Now, if you look at the question, they said, what is the volume? You're being asked for volume of energy required to burn completely 45 cm cube of methane. So what you have is methane burning. And when we talk about the burning of methane, it's called the combustion of methane. To answer this question, we need to write the equation for the combustion of methane. So question 11, for 11, let's write the equation for the combustion. All right, combustion of methane gas. All right, let's write that. The equation for the combustion of methane is that you have methane, that's CH4, burning in oxygen, that's O2. All right, and the product for combustion is usually carbon dioxide, that's CO2. So you have CO2 plus the other products will now be water, so plus H2O. Right, so you have this. So basically what you have here is the equation for the combustion of methane. Our next step will be to balance this equation here. To balance this, I have 2 moles of this. We have 2 hydrogen here. We have 5 hydrogen here. So let me balance this. Just put 2 here. All right, so that becomes 4 hydrogen, 4 hydrogen. Hydrogen is balanced. Look at oxygen. You have 2 times 1, that's 2 here. And then you have 2 here, that's 4. So let's balance oxygen. I'll just put 2 here. It becomes 4. All right, so from here, you can see that we have a balanced equation for the combustion of methane. Now, from the balanced equation, if you look at the molar ratio or the volume ratio, also known as the coefficient ratio, for here, the number here is 1. So you have 1 is to, for oxygen is 2, is to, for carbon dioxide, you have 1 here. So is to 1, is to, for water, you have 2. The number there is 2. So you have 2 there. All right. Coming back to the question here, you can call this a volume ratio. Coming back to the question, they said, what is the volume of energy required to burn completely 45 cm cube of methane? All right. So 45 cm cube of methane. Now, if I go with volume, you can see that for 1 cm cube of methane, I need 2 cm cube of oxygen. So if I have 45 cm cube of methane, I'll write this under methane. Methane is actually CH4, right? Now for 45 cm cube of methane, the number of oxygen or the volume of oxygen, let's call it X. All we have to do here is cross multiply. X times 1 gives you X. It's equal to 2 times 45. That gives you 90. All right, so that becomes 90 cm cube. So that's how you do this. All right. So let's see which option is 90 cm cube. That is option D. So for this question here, option D, 90 cm cube is your correct answer. Question 12. Reduction of nitroalkanes, nitrites, and amide is a route for the preparation of A, amines, B, alkenes, C, polymers, D, detergent. For this question here, the correct option is A, amines. Now you want to note that amines is a sole body that houses nitroalkanes, nitrites, and amides. So hence the correct answer is A, amines. Next up, question number 13. 13 says, which of the following metals burn with brick red? A, lead, B, calcium, C, sodium, D, magnesium. For question number 13, the correct answer is B, calcium. All right. So for this question, you want to note that calcium is the only metal that burns with brick red flame. All right. So whenever you see a metal burning with brick red flame, that metal is surely calcium. Okay. Next up, question number 14. 14 says the elements that belong to the third period of the periodic table are, you have option A, option B, option C, and option D. So which of this is the correct answer? Now, if you inspect this correctly, the correct answer here will be D. All right. D, you have sodium, you have magnesium, you have sulfur, and you have argon. This will be the correct answer. And why we say the third period is because recall that for, let's look at the elements in number 14. So number 14 there, the elements there are, you have sodium, magnesium, so sodium Na, magnesium Mg, you have sulfur S, you have argon Ar. Now for this particular element here, let's get the atomic number. For sodium, the atomic number is 11. And with 11, if I do my electronic configuration, that becomes 281. All right. If I use my KL Mn shell, so KL and M shell is 281. You want to observe that this has three shells there, the K shells, the L shells, and the M shells. So you have three of it. And that's why it's said to be in what, the third period. One of the elements is in the third period. You'd have just three shells, as you can see, KLM. For magnesium, the atomic number is 12. If I do the electronic configuration, that becomes 282. Again, just three shells. So it becomes a three-period element. That's an element in the third period. For sulfur, the atomic number is 16. Okay, so the KLMN shell configuration becomes 286. Again, you have three shells. And finally, for argon, the atomic number is 18. So if I do my configuration, it becomes 288. So observe that all the elements in this particular group have three shells. The first shell being K, the second shell being L, and then the final shell being M. So you have this. So all of them here are in their third period. All right. So that's how we get this. Next up, question number 15. 15 says, what is the pH of 0.001 mole per dm cube solution of sodium hydroxide? A, 14, B, 13, C, 12, D, 11. So how do we solve this particular question? So for question number 15, to solve this, the first thing we want to notice is that sodium hydroxide, that's NaOH, this sodium hydroxide is a strong base, and when it dissociates, you have that sodium hydroxide will break up into sodium ion, positively charged, plus the hydroxide ion, that's OH, negatively charged. Now, from the question there, we're given that the concentration of the hydroxide ion, that's this, is equal to 0.001 mole per dm cube. So mole dm to power minus 3. That's mole per dm cube. And this is equal to, if I write this in index form, this is something as saying 1 times 10 to power minus 3 mole per dm cube is the same thing as molar. So you have this. And of course, anything times 1 is that thing. So 1 times this is itself, that becomes 10 to power minus 3 molar or mole per dm cube. So what we have here is the concentration of the hydroxide ion. Now, after this, the next thing we'll have to do is to compute pOH. All right, let's compute this. Compute the value of the power of the hydroxide ion. All right, so pOH you have here. Let me write this better. This is written as compute P of OH. This is how you write this. And what this simply means is the power. This is the power of the concentration of hydroxide ion. That's this concentration is this concentration of hydroxide ion. So let's compute this. And how do we compute this? You want to note that the power of the concentration of hydroxide ion is equal to, the formula is negative log, of course, base 10. This of the concentration of the hydroxide ion. You have this. Right, this is what you have. Let's fix in values. This is equal to negative log, of course, log to base 10. All right, and then this value is what we already got here. All right, and the value there, look at it, the concentration of the hydroxide ion. So the value is equal to 10 to the power minus 3. This gives you into 10 to the power minus 3. You have this. So how do you solve this? All right, for this one here, you have that POH, all right, that's the power of the concentration of the hydroxide ion. It's equal to, now to solve this, recall that if I have a log of a particular number, right, what happens is that the power comes this way. So that becomes minus times, or perhaps minus 3. All right, so this power here comes this way. It becomes minus 3 times what I have here, minus log 10, that's 10 to base 10. So basically this power here came down here. Use it to multiply, that's all. From here, we know that log of a to base a, the log of a number to itself as a base is equal to 1. The same thing happens when you have log 10 to base 10. It also gives you 1. So what we are trying to say here is that for this question here, all of this, log 10 to base 10 gives you 1, and that becomes minus 3 times minus, we said this gives you 1, that's from the laws of logarithm, that becomes minus 1. So minus 3 times minus 1 gives you plus 3. So the power of the concentration of the hydroxide ion is equal to plus 3. That's minus 3 times minus 1. That gives you plus 3. Now, at this point, your final task is to note something. Note that at this particular temperature, 25 degrees Celsius, right? At 25 degrees Celsius, we have that the pH there plus POH, these two here, if you combine them, we'll have this as 14. Okay? This is constant at 25 degrees Celsius. So we'll have this. So from here, if you are to get pH, we'll have that the pH will be equal to 14. This is plus POH. Comes here, becomes minus POH. So minus POH. And that's equal to 14 minus POH. The value there is 3. So 14 minus 3. And the value here is equal to, and the value here is equal to 11. So it means that the pH is actually 11. Basically, these are the steps involved, right? The pH is 11. So let's see which option gives us 11. Back to this question there, looking at this, option D is the correct answer. That is 11. All right, next up, question number 16. Question 16 says, in the periodic table, the electrical and thermal conductivities are properties of elements that A, decrease across the period and increase down the group. B, increase across the period and decrease down the group. C, decrease, that should be, is it across? Decrease across the period and down the group. D, increase across the period and down the group. So for question 16, which of this is the correct answer? For this question, note that the correct answer is A, all right, which is decrease across the period and increase down the group. So you want to take note that electrical and thermal conductivities are properties of elements that decreases down the period and increases, that decreases across the period and increases down the group. So the correct option there is A. All right, that's the correct answer. Question number 17. 17 says P1V1 is equal to P2V2. Supports A, Charles' law, B, Boyle's law, C, Graham's law, D, Avogadro's law. For this question here, the correct answer is B, Boyle's law. All right. You want to note that Boyle's law states that the volume of a given mass of gas is inversely proportional to its pressure. So you have this. Now to solve this, we'll take off the proportionality sign, we'll put an equal to and bring a constant. So V is equal to, put a constant, dot, write this one back. That becomes 1 over P. All right. If you multiply this, we'll have that V is equal to K times 1 gives you K all over P. This is all over 1. If I cross multiply, K times 1 gives you K is equal to P times V gives you PV. So you have PV here. If I relate these at two different points, points 1 and 2, you have P1 V1 is equal to P2 V2. So basically, this is Boyle's law. Of course, temperature should be kept constant. So the correct answer there is B, Boyle's law. All right, next up, question number 18. 18 here says, which of the following ions require the most quantity of electricity for discharge at the electrode? A, 2 moles of, you have Q 3 plus ion. B, 2.5 moles of R 2 plus ion. C, 3 moles of T, you have minus 1 ion. Then D, you have 4.0 moles of Y minus 1 ion. So which of this is the correct answer? Now, to solve this question, all you have to do is consider each of the given ions, Q, R, T, and Y. So I'll take Q. Right, for Q, all you have to do here is multiply the number of moles, which is 2, times the number here in the ion, which is 2 times 3. All right, this is how to get the charge. So the number here is 2, that becomes 2 times, you look at the number here, that's the power or the charge of the ion, which is 3, and that's equal to what there? 6. So Q needs 6 units, that's the charge. For B there, B, what you have there is 2.5 moles of R. So for R, the number there is 2.5 times what's its charge? Each charge is 2 plus, or let's just say 2. So times 2. 2.5 times 2, that gives you 5 units. Okay. Next up, for T, so we have T is equal to, the number of moles is 3. So 3 moles times, the part there is negative 1, but we don't use the sign, just take the number. It's negative 1, but it's still 1. 3 times 1 gives you 3 units. Then finally, for D, you have 4 moles. So for Y, all right, D, you have Y, all right, Y minus 1. Number of moles is 4, so it becomes 4 times 1. Again, you don't include the sign, just take the numbers. 4 times 1 gives you 4 units. So which of these has, or which of these needs the most quantity of electricity from here? Obviously, you have 6 units from Q. That's your correct answer. So for this question here, we're going to take this off. The answer there is A, 2.0 moles of Q ion 3 plus. That's it. That's how you solve this question. Next up, moving on, question number 19. 19 says the reaction of sucrose with dilute hydrochloric acid produces A, an alkaline, B, glucose and fructose, C, a black mass of carbon, D, polysaccharide. For this question here, the correct answer is B, glucose and fructose. For this question here, you want to take note that the end product of the reaction of sucrose and HCl, that's hydrochloric acid, which is diluted, will yield glucose and fructose as the end product. All right, so that's your correct answer, B. Next up, question number 20. 20 says a compound contains 31.91% potassium, 28.93% chlorine, and the rest oxygen. Right, the rest is oxygen. What is the chemical formula of the compound? They give you K there, the atomic mass of potassium as 39. They give you Cl there, atomic mass of chlorine atom to be 35.5, and then oxygen, atomic mass at 16. You have option A, option B, option C, and option D. So how do you solve this question here? Now, what we'll do is very simple. For each of them, let's try to get the elements involved. You have potassium, that's K, chlorine, Cl, and then oxygen. So you have potassium, K, you have chlorine, Cl, you have oxygen, so you have O. Let's get their percentage composition. For potassium, you have 31.91%. So this is 31.91%. For chlorine, you have 28.93%. So you have 28.93%. And then they now said the rest is oxygen. So how do you get that value of the rest in quotes? Now, you want to note that for any given compound, if I combine all their percentages, let me call this X. If I combine all of their percentages, this and this and then this, it should be equal to 100%. So what we're saying here is that 31.91 plus 28.93 plus this unknown X should be equal to 100% or 100. At this point, all we have to do is to sum the first two values. That becomes 31.91 plus 28.93. If I sum the first two values, I'll have this as 60.84. This plus x is equal to 100. The value of x here is equal to 100 minus 60.84. Let's subtract this. 100 minus 60.84. The value there is 39.16. So the percentage of oxygen is 39.16. All right, let's write down that value. So from what we've calculated so far, the value of x here is 39.16. All right, so what we have here is my first value. We've now gotten the percentage composition of oxygen. Our next step here would be divide each of them by the atomic mass. They gave you for potassium 39, so divide for potassium by 39. For chlorine, divide by 35.5. For oxygen, divide by 16. So this becomes, for this, divide this by 39, divide this here by 35.5, divide this here by 16. So I have this. All right, if I divide this one here, this value here, if you punch this, your value gives you 0.8182. This second value here, if you divide this, all right, your value gives you 0.815. That's your value. This value here, if you punch this, divide this, you'd have your value as 2.448. So this is your next task here. Then after this, your next task is to divide by smallest value. Divide by smallest value. Excuse me. Divide by smallest value. So which of these values, all right, these three values there, which of them is the smallest? Obviously, the smallest there is 0.815. Here's the smallest value. So let's bring it this way. I'm just going to rule this line. All right, let's divide by smallest value. So we have for K, we have for chlorine, and we have for oxygen. For K there, you have 0.8182. So 0.8182. For chlorine, you have 0.815. For oxygen, you have 2.448. So you have 448. Divide this by the smallest value for all three. That's 0.815. Divide this by smallest value 0.815. Divide this by 0.815. Now, if you do this division here, that's 0.8182 divided by 0.815. You have your answer as 1.003, which is approximately 1. For chlorine, of course, this divides itself. You have your answer as 1. Next up, if you do 2.448 divided by 0.815, you have your answer as 3.000003. So basically, I have 113. So combine this to this. So potassium, you have K. All right. For potassium, the value there is 1. Next up, you have chlorine, also 1. So Cl, you have 1. Oxygen, you have 3. So you have O3. Let's combine this. If I combine this becomes K, then ClO3. Right? There's an invisible one here. There's a 1 here. But we write it as KClO3. That's what you have here. So let's see which option meets this. KClO3. So looking at this, the correct answer there is D. All right, the correct option is D, KClO3. So that's your correct answer. Question 21 says, which of the noble gases has the greatest ionization energy? A. Helium. B. Xenon. C. Argon. D. Rhenium. So which of this is the correct answer? So for this question here, you want to take note that the correct answer is A. Helium. All right. Note that helium is the noble gas with the greatest ionization energy because it is less stable. So A. Helium is the correct answer. Question 22. 22 says the alkyl group can be represented by the general formula. You have option A, option B, option C, and option D. Which of this is your correct answer? Now you want to take note that for question number 22, when we talk about the alkyl group are derived from the alkanes by the loss of one hydrogen atom. The alkanes, your general formula is CnH2n plus 2. All right. If I lose one hydrogen atom, this becomes minus 1. 2 minus 1 here gives you 1. So I'll have that as 1 here. All right. So that means for the alkyl group, the general formula is CnH2n plus 1. Let's see which option that is. So looking at this, we can see that option A matches that. All right, CnH2n plus 1. That's this. All right, although they did not write the 2 very well, but then that's your correct answer, option A. Question 23. The oxidation state of chromium Cr in this is potassium heptaoxochromate is A 7, B 6, C 5, D 4. So how do you solve this question? Now you have K2Cr2O7. Okay, let's write this out here. So you have K2Cr2O7. You have this. And this is for question number 23. Now, how do you solve this? The first thing you want to notice that potassium, the ionization part there, all right, for potassium there, the oxidation number is plus 1 times number of atoms here, 2, plus for chromium, we don't know the oxidation state. Let's call it X times number of atoms here, 2, plus for oxygen next, its oxidation number is minus 2 times number of atoms, 7. This will equate this to 0. So this is equal to 0 because there is no plus or minus attached to this. All right, it was just this, which is a stable atom. From here, 1 times 2 is 2 plus x times 2 is 2x plus minus 2 times 7 is minus 14. So minus 14 equal to 0. Working on this, you have 2 minus 14. Of course, plus minus is minus. 2 minus 14 is minus 12. Minus 12, bring this back, plus 2x is equal to 0. Move this over here. You have that 2x is equal to minus 12 becomes plus 12. So I have plus 12. So I have this. Divide by 2, divide by 2. This cancels this. So x is equal to 12 over 2 gives you 6. So the value there, or the correct answer is 6. So it means the oxidation state of chromium there is B6. Hence, this particular compound is called potassium heptaoxochromate 6. All right, because 6 is the oxidation state of chromium in this compound. Next up, question number 24. 24 says the intermediate product formed when ethanol is progressively oxidized to ethanoic acid with potassium heptaoxodichromate 4, all right, is A, butanol, B, ethanol, C, methanol, D, propanol. For this question, the correct answer there is ethanol. All right, it's not in the option there, but it's supposed to be ethanol. So I guess this B was supposed to be ethanol and not ethanol. Okay, you want to note that ethanol is formed as the product when ethanol is progressively oxidized to ethanoic acid with potassium heptaoxo dichromate 4. So the correct answer should have been ethanol, right? Next up, question number 25. 25 says NH3 in gaseous form, that's ammonia gas, plus HCl, that's hydrogen chloride gas, combines to give you ammonium chloride as a solid. They said the entropy change in the system above, that's this is A, positive, B, 0, C, negative, D, intermediate. All right, so what's the correct answer here? Now, for this question, the first thing you want to notice that they ask you for entropy. That's this one here. They ask for entropy. And normally, entropy simply measures disorderliness or disorder. And looking at this, we know that gases have much higher entropy or much higher states of disorderliness than solids. And I'm saying this because looking at this, you can see that the reactants are gases. Meanwhile, the product is a solid. And the reason why gases have higher entropy is because their molecules are free to move about and occupy many more microstates as compared to solids. Again, trying to look at this equation here, you can see that initially there are two gas molecules. That's ammonium in gaseous state and hydrogen chloride gas, and these are highly disordered. Now, after the reaction, what do you observe? You now have one solid state or one solid product there, ammonium chloride. The first one was ammonia. Now you're having ammonium chloride. Next up, consider the system change. Now, moving from two gas particles to one solid particle drastically reduces the number of molecular freedom and disorder. So the entropy of the system decreases. All right, the state of disorderliness or randomness this decreases as it moves from gaseous state to solid state. This means that there will be a decrease in the entropy. So the entropy change becomes negative, signifying a decrease. So the correct answer to this question is C, negative. Next up, question 26. 26 says nitrogen crude oil is described as light crude because of its A, low sulfur content, B, high natural gas content, C, high octane number, D, low aliphatic hydrocarbon content. For question number 26, the correct answer there is A, low sulfur content. Now, for this question, you want to take note that light crude oil, also called sweet oil, is a type of crude oil with low sulfur content. In a way, it costs less to be refined. All right. So the correct answer there is A, low sulfur content. Next up, question number 27. 27 says a good drying agent should be A, deliquescent, B, effervescent, C, hygroscopic, D, efflorescent. Now, for question 27 there, the correct answer is C, hygroscopic. All right. A good drying agent should be hygroscopic. And when we say hygroscopic, what does that mean? Now, when something is hygroscopic, it simply means that it absorbs water from the atmosphere or the surrounding in which it is placed. And if it should be a drying agent, it should be able to absorb moisture or water from wherever it's kept. And that's why it should be hygroscopic in nature. That's your answer. 28. A major source of oxides of nitrogen is from the burning of A, coal, B, wood, C, fuel, D, chlorofluorocarbons. Now, for this question here, the correct answer to question 28 is A, coal. You want to note that coal is a major source of oxides of nitrogen. All right. Hence, nitrogen is usually got by the burning of coal. So that's your correct answer. Next up, question number 29. 29 says the energy value of petrol can be determined by A, bomb calorimeter, B, catalytic cracker, C, fractionating column, D, thermometer. For question 29, the correct answer there is C, fractionating column. Now for 29, you want to note that when we say fractionating column, it's a column that contains petrol with different density, and it is the only container that houses a fluid of such varying density. So the correct answer there is C, fractionating column. All right, let's look at the last question for this particular video. Question number 30. 30 says hydrogen can be displaced from hot alkaline solution by A, iron, B, copper, C, copernicium, D, tin. You have this. So which of this is the correct answer? For 30, the correct answer there is iron. All right. So you want to take note that hydrogen can be displaced from hot alkaline solution by iron. Iron is the correct answer. Question 31 says, in countries where the temperature falls below 273 Kelvin, salt is always sprinkled on the road in order to A, lower the melting point of ice, B, increase the density of the ice, C, make the ice impure, D, raise the melting point of the ice. So which of this is the correct answer? For this question, the correct answer is A, to lower the melting point of ice. Now, when salt is sprinkled on ice, what happens is that the melting point of ice is being lowered. And what this means is that ice quickly turns into water or liquid, which then vanishes. So if we have ice lying on the road and we want to eliminate the ice, all we have to do is to sprinkle salt on it. And when salt is sprinkled on the ice, its melting point is being lowered, which means just a little increase in temperature will melt the ice, giving us a normal road, right? That's a road without ice. So hence, to lower the melting point of ice, we'll sprinkle salt on it. So that is why A is the correct answer. Next up, question number 32. 32 says, what volume of 0.5 mole per dm cube H2SO4 hydrogen tetroxysulfate 6 acid will exactly neutralize 20 cm cube of 0.1 mole per dm cube sodium hydroxide solution? A, 2 cm cube, B, 5 cm cube, C, 6.8 cm cube, D, 8.3 cm cube. So which of these is the correct answer? Now for 32, we are given 0.5 mole per dm cube. What you have here is a concentration. So let's call this, since we have two values of this and this, let's call this the first concentration. So you have this as C1, and they said what volume of this? So the volume of this one here is unknown. V1 is equal to unknown. Then you have a second volume here, which is the volume of this other concentration. So in essence, we'll be using the C1V1 equal to C2V2 formula. But before we do that, the first thing we want to do here is I want to write a balanced equation of this reaction. All right, let's write a balanced equation of this reaction. For this reaction, what we have here is a neutralization reaction. That means an acid will react with a base to form salt and water. So for this, what's the acid there? The acid there is H2SO4. So write this down for 32. For 32, you have hydrogen tetroxysulfate 6 acid. This combines with the base. The base here is sodium hydroxide, that's NaOH. When acid combines with base, what does it form? It forms salt and water. All right, so let's get the salt and the water. For this, the salt that we formed obviously would be NaSO4. So you have NaSO4, sodium tetroxysulfate. This is actually Na2SO4, Na2. So you have this as Na2SO4. This plus, of course, water. That's H2O. So plus H2O. All right. So this is the equation of the reaction. Let's balance this up. We can see two hydrogen. That's balanced. Sodium, you can see two sodium here. Right. You have just one sodium here. So I'll put 2 here. All right, so that balances the sodium, but you now have 2 and 2, 2 hydrogen. Okay, so let's put 2 here. Let's see what we have here. All right, at this point, the equation is balanced. If I do my molar ratio comparison, this is 1 is to 2 is to 1 is to 2. So you have 2 as the number of moles here. You have 1 here. You have 2. That's why you have the 2 here. And then you have 1. There's 1 here. That's why you have this 1 here. So basically, let's just call it coefficients. All right. So the number before each of the compounds is what I'm writing here. So that's the first thing you do. Now you want to know that this is called the number of moles. All right. It's called the molar ratio. So what you have there is molar ratio. From here, you can say that it takes 1 mole of this H2SO4 to neutralize 2 moles of sodium hydroxide, NOH. That's it, 2 moles of this. All right. So with this, we can use the formula CAVA all over CBVB is equal to number of moles of A all over number of moles of B. Right? C simply means concentration, V means volume, N means number of moles. A is for acid and B is for base. All right, let's put in these values. Ca, concentration of acid. Let's see what they give to us here. They said what volume of 0.5 mole per dm cube H2SO4. So what you have here is Ca, that's the concentration of the acid, 0.5. Okay, so you have 0.5, that Ca is 0.5. Va, they're asking for what volume of the acid, we don't know, we'll call it Va, all over. For Cb, let's see concentration of base, said will exactly neutralize 20 cm cube. So the volume of the base is 20, 0.1 mole per dm cube. This mole per dm cube tells you about concentration. So the concentration of the base is 0.1. Meanwhile, the base volume is 20. So let's impute those values. So concentration of base is 0.1. The volume of the base is 20. So you have this. All right, this is equal to number of moles of the acid from here, N of A. We had 1 mole of the acid, so it becomes 1 all over. So it becomes 1 all over number of moles of the base, 2. Right? It will neutralize 2 moles of the base, NaOH. All right, so from here, let's get the value of Va. Simply cross multiply this times this. You have 2 times 0.5 times Va, volume of acid. It's equal to this times this, 0.1 times 20 times 1. All right, let's impute these values. What do we have here? Of course, 2 times 0.5 is 1. So 1 times Va is equal to 0.1 times 20 is 2. 2 times 1 is 2. From here, we'll have that 1 times Va, volume of acid, is equal to 2. Using your units there, 2 cm cube. So let's see which option there is 2 cm cube. Looking at this, the correct answer is A, 2.0 cm cube. So that's the correct answer. All right, question number 33. It says S block elements of the periodic table are made up of A, group 1, 2, 3, B, group 1 and 2, C, group 3, D, group 3 to 7. Now you want to note that when we say the S block elements, the S block elements are the alkaline metals and the alkaline earth metals. The alkaline metals, what is that? Alkali metals are simply those elements in group 1. Let me write this group G1, that's group 1. Meanwhile, the alkaline earth metals, let me use capital A here. The alkaline earth metals, are those elements in group 2? So the correct group 2, G2, that's group 2. All right. So these two sets of elements make up the S block elements. Okay. So the answer is group 1 and group 2, which is option B here. Group 1 and 2. That's the correct answer. So note that the alkaline metals of group 1 and the alkaline earth metals of group 2 form the S block elements of the periodic table. Next up, question number 34. For 34, you have this one here. This is chloroethane combining with potassium cyanide, resulting in the formation of ethane cyanide plus potassium chloride. The question here says, in the above reaction, the cyanide is A. Hydrophobic, B. Hydrophilic, C. Nucleophilic, D. Electrophonic. So for question 34, what's the correct answer? For 34, the correct answer is C. Nucleophilic. Now you want to note that nucleophilic potassium cyanide is an explosive compound that is used mostly for nuclear energy. All right. If you look at this there, option A, B, D are not explosive as they are not used mostly in nuclear energy. So the correct answer here becomes C. It's nucleophilic. That's your answer. Question 35. Electronic configuration of an element 13x in the subsidiary energy level is, you have option A, option B, option C, and option D. Now, when you have 13x, it simply means an element with atomic number 13, which is this. All right. So how do you correctly write the SPDF configuration for elements with atomic number 13? That's what they're asking you for. Now, one of the easiest way to get this particular question is to note that if I count the pairs there, right? If you count the pairs there, it should be equal to this value 13. If you look at A there, if you count the pairs there, the pairs here is 2 plus 2, that's 4, 4 plus 6, that's 10, 10 plus 2, that's 12, 12 plus 1, that's 13. So just hang on. Look at B. If you count the pairs there, 2 plus 2, 4, 4 plus 4 here, this 4 here, that gives you 8. 8 plus 1, 9, 9 plus 1, 10. So it cannot be B because 10 is not up to 13, so it cannot be B. Looking at C there, see, if you count the pairs there, 2 plus 2, 4, 4 plus 6, that gives you 10, 10 plus 2, that's 12, 12 plus 3, that's 15. So it cannot be C either. Again, looking at D, 1 plus 2 is 3, 3 plus 6 is 9, 9 plus 2 is 11, 11 plus 4 is 15. So you can see that the only one that matches our answer there is A. Or that will give you 13 if you count the pairs. Again, you want to note that when it comes to SPDF configuration, for S, the maximum pi is 2. All right, for P, the maximum pi there is 6. You can see there. All right, so A is the correct answer. We've done a complete video on electronic configuration. All right, so go to the JAMB and Chemistry playlist, and then you see the chemistry video on electronic configuration. You see how to do electronic configuration of elements in both KLMN shells and SPDF configuration. Moving on, question 36. 36 says the acid in electrolysis of water is dilute A, HNO3, hydrogen trioxynitrate 5, B, CH3COOH, that's ethanoic acid, C, H2SO4, hydrogen tetraoxosulfate 6, D, HCl, that is hydrogen chloride. So which of these is the correct answer? For 36, you want to note that the correct answer is H2SO4, hydrogen tetraoxosulfate 6. All right, so note that hydrogen tetraoxosulfate 6 is the acid used in the electrolysis of water. All right, and of course we can't use A, B, and D because especially if they are concentrated, they can react to the water, so they are not suitable. The correct answer should be H2SO4. So that's your answer. Next up, question 37. 37 says, calculate the relative molecular mass of limestone. All right, that's CaCO3. They gave you the formula of the compound. So they said, take Ca equal to 4. That is the atomic mass of calcium as 4. For carbon, they gave you the atomic mass as 12. For oxygen, they gave you the atomic mass as 16. Option A says 56. option B 100, option C 76, and option D 90. Which of these is the correct answer? All right, let's get relative molecular mass of CaCO3, 37. So for 37, calcium trioxocarbonate 4. Let's get the molecular mass. This is equal to, for calcium there, we know that the atomic mass is 40. So 40 plus, for carbon there, the atomic mass is 12 as given. So we have 12 plus, for oxygen, the atomic mass of oxygen is 16. 16 times, you have 3 atoms of it. All right, so it becomes 3. And this is equal to 40 plus, this is 12 plus, this will give you 48. All right, 16 times 3 is 48. If I combine this, 40 plus 12, that gives you 52. 52 plus 48, that gives you 100. So you have 100. Molecular mass is measured in gram per mole. That's gram per mole. All right, so we have this. So let's see which option that is 100. The answer is B, 100 in gram per mole. You have this. All right, next up, question number 38. 38 says the oxidation state of oxygen on tetraoxosulfate 4 acid is A -4, B -2, C 4, D -8. So for this question, you want to know that the ion